you need to make sure you know these 3 things for each person at your table. Let me give you an example. Hello, my name is Ms.Stolte. I'm 5'11", and if I recently moved into an apartment building from my house, so now I'm in an apartment, and if it was catching on fire and the fire department came like, girl, you gotta evacuate. I'd be like, all right, here are the 5 things I would grab. A, my dog. B, I forget what I said. She really is my dog. No, because I'm a little bit realistic about this. I've had to evacuate before from fire. I used to live in California, and Santee, the hills, you know, the hills would catch on fire like every summer, and my house was right on this hill. And hi, what? Just grab my bike, because realistically, if I was just trying to grab and get, like, that's gonna be too much for me. Okay, but I got my dog. She's on her leash. Okay. Oh yeah. Hey. Shh. Shh. I made this game up. It's my rules. I can say whatever I want. Okay. I grab my dog. Oh, I'd grab my. This is a cheater one, but my backpacking pack. It's up above my closet now. I just moved like this weekend, so I know where everything is. I'd grab that, and inside of my pack. Inside of my pack is some fuel, a small backpacking stove, some pots and pans, and a water purifier. So that'd just be like survival. Okay. No, shh. I grab that. My dog. Oh yeah, my journal. I grab my journal. Huh? What is in journals? What do you mean? Have you ever words? Like what? Kimani, what kind of question is that? In my journal, dear journal, today Kimani was a big jerk and he made fun of you. Sincerely, Ms.Stolte. It's not a journal. Kimani, what's so special is my reflections as I go through life. So I get to look back, and I have it's not like a diary. It's not like a account of like today I did this. It's that's not how I. No, shh. It's not what it is, Kimani. What it is more of a reflection of the current events in my life. So, you know, like this is going, and then I get to look back. I've kept this since I was in high school, and so it's always fun. Like I look back at some of the stuff I wrote in college, and it's like, ooh, or in high school. Oh my God, like, oh, I know everything. I'm so smart. Like everyone, my mom, like, ew, what's her deal? And then like now I'm like, oh my God. Thank goodness we grow up. You'll say that at some point. Okay. My dog, my pack, my journal, my phone. Oof, what was number 5?
Your charger.
I'm probably wearing clothes, okay? Clothes are just things. I'm talking about things I can't replace. You guys.
Shut up.
Shh. You guys, there was something really good, and you're all distracting me.
Your money.
No, listen, okay?
Money. Shut up.
I guess I'll change it to 4 things. I don't know. I don't remember.
My height, I'm like 7'8".
My grades are going to come out.
Your grades are online. What do you think this is? Your grades are online. They're not on my computer. Do you know how the internet works?
All yours better laughing.
You guys have a few minutes in your groups. Please have those conversations. That's the angle I want to know. Using what you know about triangles and the stuff we've learned, I want you to take 2 minutes to come up with what you think. You can't be wrong if I ask you what you think. What you think or how you think you might be able to calculate this angle. Okay? How can you possibly be paying attention when you're not even looking at me? Interesting. Okay? 2 minutes. Talk in your groups. Come up with what you think might be an idea. Ready, set, go. I see people doing this one. Meadow's kind of only confidently raising her hand. Go ahead, Meadow.
Well, Hannah and I thought that if you take, from like where it says 16 1/8, if you cut it right at that angle along, then you know how.
This way?
Yeah. Then you know how long that board right there. If you
But that's this length, right?
Yeah, and then you'll know all the side length. And then we couldn't quite remember, because if we were pretty positive we get a 90-degree angle, but we weren't positive that
This
yeah,
one?
that one, we're pretty sure, because like if we cut it right. And then we didn't really get past there, but we figured out how
Okay.
close side lengths to try and find them right angle.
So what do you guys think about that? Because I'm just going to preface with this. If you weren't sure, I'm not having this discussion for me. It benefits me zero. I actually do know the answer to my posed question, right? Like, I'm asking you guys to explain this so that you can think about it. So you can try and connect where you're at, what you do know, to where we're going. That's actually the entire process of how you learn. So Meadows talking about this, and I want you guys to evaluate if what she's saying makes sense. Does that resonate? Okay, so
Not have anything to do with how you find that angle. It helped make it
just be confident, lady. We have a triangle on here. I appreciate that.
triangle.
Okay, Meadow is saying that she can know this. She can know all the side lengths, and that could help find the angle. Thoughts, Chris?
I'm just gonna add, I was thinking for my method is that on the hypotenuse on both of them is the same, and so if you put a line from where she started all the way through, it would be a equilateral triangle.
Hold on. Evaluate what Chris just said. Is that going to be an equilateral triangle? No, you both. Because
It wouldn't be equilateral.
equilateral, remember, all sides the same.
Yeah, it wasn't. No, it would be.
Okay. Isosceles. Mickey.
Okay, once we know the size, each angle relates to its opposite.
Do we know the sides?
Yeah.
You guys know these sides?
We know the sides are positive.
I have a question. Does anyone share my question? No.
Well, if you have all the measurements, then aren't you sure what the sides are?
Do I have that measurement?
No,
Wait,
you
no,
have,
you only have part
you
of
have
it.
the whole line. That's just a portion of it.
Yeah. Oh, okay. Go ahead, Levi. Say what? Okay. Do you guys agree with that?
Yeah.
Because we know this one, right?
Yeah.
And we know that one. So I'll say, sure, we could get that. Okay.
But
Go ahead.
well, this can't pinpoint an exact angle, but since that would not, if you mirrored it across the bottom leg, it wouldn't be an equilateral triangle. You know it isn't 30, 60, 90. And since,
Hold on. Let us evaluate that. He said if we mirrored it, I don't know how much. Like, I don't know how much. If we mirrored it, he said it wouldn't be an equilateral triangle. Do you guys agree with that?
Yes.
Yes, because Mickey said it.
You know what? I'm not gonna say it.
well,
Is that equilateral?
You don't know.
You have to find the side angle first.
actually, I did quickly, I didn't cross it out and it wouldn't be close to equilateral. I mean, I don't know for sure, but I'm like 90% positive. And since
Hold on. We still gotta evaluate. How do we proceed, class? Do you guys want to? Is anyone disagreeing? Do you think this is equilateral? Do you know?
I think that it is impossible to tell or to get the answer right now because we have no angle
that's not
measurement.
true.
Hold on.
And we need at least one angle measurement in order to be able to finish this.
Okay, that's how you're. So you're at like if I knew one angle, I could find the other one.
We do know one angle.
No, we don't.
We know the 90-degree angle.
And how are you certain of that?
It could be 91
I'm
or it could
confident
be
Ms.
89.
Stolte trusted. I think she
I didn't design this. This is from Summit Crest Homes. I don't.
I'm confident they're trusted.
If your king post, hold on, Arden.
Assume that the trust
Hold on. Let's not assume. If your king post isn't 90, If your studs are not 90, you ever seen a house going like this? Not for very long, because if a house is going like this, it's crashing.
Like a wrecking ball.
Yeah, so here's the deal. On the plans, right? On plans, guess what? They don't give you any angles. You'll never see angles on plans, ever. They don't tell you that your king post needs to be 90. But it is definitely assumed that you should probably be making your studs
Even.
90. You should probably be making your king post straight up. So you don't have a roof that's like, right? So it's not necessarily an assumption so much as it is that's the way you have to build to be structurally sound. I'm going to go ahead and point this out that if your head is on the table, not okay. So we're just going to keep them there. That's cool. Okay? Absolutely not okay. Guys, I realize that you might be tired. I realize, whatever.
You said June.
Okay? It's not acceptable. Stop, Levi. It's not acceptable to have your head on the table. Okay? Okay. Hold on. So I think this is where we're going. Was this a 30, 60, 90 triangle?
To be determined.
Determine. Go ahead. In your groups, decide what does it mean to be a 30, 60, 90 triangle? What is special about the size of a 30, 60, 90 triangle? And decide if that is one. You have 30 seconds. Go. Meadow.
Well,
Shh.
hypothetically, if because of the longest leg should be the shortest leg times the square root of 3, right? So if that doesn't work, then it's not a 30, 60, 90 triangle. Or if the hypotenuse isn't the short leg doubled, then it isn't a 30, 60, 90 triangle.
Okay, remember, yes, I'm going to reiterate that because Meadow's like on point, and if you're not hearing her, you should be. Okay? The short leg on a 30, 60, 90 right triangle, the short leg is half the hypotenuse. The short leg is half the hypotenuse. What's this length right here? Someone who's calculated, tell me.
It's 19 and 6/8.
Cool, we'll leave it. 19 and 6/8 by subtracting. Doesn't matter. Hey, you did Pythagorean theorem, yeah? Did you do Pythagorean theorem on this?
I don't have a calculator.
So no? So when you said you did, what was that about?
I said we could.
Crazy cat. Okay.
Never said I did.
You know you're tough.
You did say you
How about this?
Wait, if
The whole thing is
Because that's half of that.
isn't half of 5/8.
Half of 5/8 is 5/16.
I thought it was 10, 16.
No, 10/16 is 5/8. And then we divide that by 2.
Okay. Hey, you're gonna write about that later. Hold on to it. Remember it. Okay.
You say writing?
You too. Ooh.
I didn't know that you
Well, time out. It's gonna be. I'll make up for it. Okay. Did anyone decide if this was a 30, 60, 90 right triangle? Meadow was saying if the short leg times the square root of 3, that's the relationship on a 30, 60, 90 triangle. If it doesn't fit that relationship, it's not. Do we think 30, 60, 90 or not? All right, cool. So how are we going to find that angle? Cool.
I don't know.
Okay, yeah, we don't know. Here's the deal, though. You need to know. We're going to move on from this conversation. Stop. No. We're going to move on from this conversation. And try and see something else. Something else. Put your hands down. We're moving on. Flip your paper over.
That was a backup.
Actually, I lied. I'm sorry. Open your notebooks. Way off.
Open your pages to page book 1. Open your pages to book 3. That was funny.
Oh my god.
That's not an invitation. Zip. In your notebooks. We are talking about G4 trigonometry, the study of triangles. Today specifically we are going to talk about trig ratios. Now I'm just warning you, after having taught this for 6 years, this page is going to be one of the most referenced pages in your notebook. If you choose to not pay attention to the next 3 minutes, you aren't going to have a clue what's going on the whole unit. Okay? It's not complicated. It's not like incredibly complicated. But if you don't pay attention to it, you're going to struggle. It's brand new stuff. There's no reason why any of you should not pay attention right now. Okay? We're going to be talking about trig ratios. Before we do, we need to have the common language of how we talk about the sides. This is why you would be really messed up. If you don't know the language that I'm saying, how are you going to learn what you're supposed to do? You will not. Okay? So, first off, we're going to draw a big old right triangle. It's going to be beautiful. And specifically, we're going to talk about how we label sides, okay? If we are starting from some angle, we're going to call it x. If we are starting from x, one side we all know on a right triangle is what? Let's try that again. If you said angle when I said side. One side we all know on a right triangle is the hypotenuse, right? This one right here. HYP. Also known as the hypotenuse. You will see me abbreviate it as HYP often. Now, the next two sides depend which angle I'm starting from. Right? When I talk about these, right, that depends on the angle. Okay? If I'm talking about this angle, x, which leg, the short one or the long one, which leg is the opposite side? The short one, because I can draw an arrow from my angle to the opposite side, and this would be opposite. OPP or opposite. Now, hopefully, since I maybe gave you that spiel, your brain is at the front and your frontal lobe is working. If I'm talking about this angle, right, is this the opposite side? If I'm talking about this angle, this one, right, this is not the opposite side for this angle here. This is the opposite side only for that angle. If I move and I start talking about this, I've got to find out the new opposite side. Dear God, someone wake up Malachi. Okay? So, right, if I were to redraw this and I were to talk about this angle up here, now this would be the opposite side. And that, what I just said, is why some of you guys are going to get confused. Because some of you guys are not listening. You're drawing this, and then you're just going to like always think that side's the opposite, and you're going to be real confused. It's opposite the angle. It's opposite the angle. These are relative terms, meaning they change depending on your perspective. Okay? The hypotenuse, fortunately, doesn't change. We should all know the hypotenuse. Now, if that's the opposite side, then we call the side next to the angle, we call it the adjacent side. We call it the adjacent side. Now, really, when we're talking about this, an angle has two adjacent sides, right? There are two sides that make up an angle. But one of them has a special name because one of them is the hypotenuse. Okay? It's the hypotenuse. Okay? So,
If you're using the right angle as the x.
good question. You will never use the right angle. Because here's the deal. We're usually talking about what angle we know, or we're trying to find an angle. We know the 90. We don't need to find the 90. So we don't really talk about, you'll never start from 90, because it's already 90. We already know it. Okay? So, opposite, adjacent, hypotenuse. Here's what you're going to do. On that sheet of paper, directions are a lie. Directions are a lie. You are going to measure each side to the how you normally measure. Measure each side like normal measuring is going on. Okay? So, normal measuring. I want everyone, you have rulers, take a moment on the first triangle. I'm going to give you 45, maybe a minute. Write down the lengths for that first triangle. Just pay attention real quick, and then we'll get back to you working on the measuring thing. Okay? Here's what you're going to do for each of these triangles. This first thing, I'm going to calculate a ratio. It's dividing. Okay? I'm going to calculate the ratio of the opposite side divided by the hypotenuse. Looking at that triangle, which one's the opposite side? 7/8, right? Because we're talking about from x. This would be opposite. What's the hypotenuse? 2. Beautiful. So, I need to divide 7/8 by 2. First, I need to get 7/8 into a decimal. My calculator, I need to be sure that I do 7 divided by 8 is 7/8. To get 0.875. I do not round my measurement ever. This is something we measured. I'm not going to round it, okay? So this is really 0.875 inches. Let's suppose, because you're going to need to eventually, I wanted to turn this into a decimal. I don't put 1 and 13/16, right? The decimal is going to be 1 point something. I need to know how to get that 13/16 into that something. How do I turn it into a decimal? So I do 13 divided by 16. Notice I didn't include the 1. 13 divided by 16 is 0.8125. So that this is really 1.8125. The 1 is just 1. Okay? So now, here, if I'm trying to calculate, again, opposite divided by hypotenuse, I'm going to do, opposite was 0.875. Divided by my hypotenuse, which was 1.8125. Just kidding, it wasn't. Wasn't that? JK. My hypotenuse was 2. So I divide those two numbers. Opposite divided by hypotenuse. 0.875 divided by 2. This number here, the ratio, when you divide the two sides that are both long decimals, when you divide your two sides, I want you rounding this to the nearest tenth. That's 1 decimal place. I want the nearest tenth. Down here are going to be the nearest. So when I do the opposite side divided by the hypotenuse, for that small triangle, I got 0.4. Clarifying questions before you start. Finn. Yes. The opposite divided, yeah, this one was opposite divided by hypotenuse. This one, now I'm going to do adjacent divided by hypotenuse. So now I would do 1.8125 divided by 2. I would do opposite divided by adjacent, 0.875 divided by 1.8125. Okay? Each time rounding to the nearest tenth, 1 decimal place. Okay? You're going to repeat that process for all 4 triangles. Conveniently, there's 4 of you at your table if you so choose to trust each other's work. I know you just met. Maybe you want to break it up and then check each other's work. Something like that. Okay? I would like you guys to be done with all 4 triangles and the ratios in no longer than 10 minutes. Let's listen up, please. All right. Here should have been pretty stinking close. Here were my ratios. The 2 sides divided by each other for that first triangle. I'm only wanting people who feel like they are very accurate and precise, or at least they tried hard. Can't answer these. For the second triangle, opposite over hypotenuse, what was the ratio we got? Matthew? 0.4?
0.5 actually. 0.5.
Well, it was 0.5, so there's debate on whether you keep it at 0.4 or round it up to 0.5.
Round it up.
So,
Always.
like,
Let's talk about our measurements, shall we?
How about you go back to your group?
I don't see how any research process you got now.
Do we have 1 5/8?
Yes.
Yeah. And that's 3 and 7/16. And then 3 and 1/16.
Okay? Let's make sure, peeps.
What are you?
Ms. Stolte, we got it wrong because on our rulers it looks like it was 9/16, not
Thank
5/8.
you. Thank you.
My ruler
7/16.
30 on it.
Here we go, officially. Look, you should have been dividing. I don't know what we're going to get.
Oh.
1.625 divided by 3.435. 0.5. I'm going to keep it. What'd you get for this one? I know. I'm waiting. For the last one.
0.5.
What'd you get for this one?
0.4. 0.8. 0.5.
There's a pattern.
Why are you doing the last one?
What'd you get for this one?
Same thing. 0.4.
Are you?
They're just similar triangles.
Oh, hey, look. Yeah. Little note. These are all similar triangles. What does it mean? Arian, will you please turn and face me? What is it? Yeah, say it again, Matthew.
They all have the same angle.
They all have the same angles. Now, here's what's important. Similar triangles, some of you guys missed this one on your test. Similar triangles are similar if they share the same angles, if their angles are exactly the same and they're just scale versions of each other. All these triangles are just scale versions of each other. Hopefully, we're right enough to recognize. We recognize that they're not all the same length. That's crazy stuff, right? They're not all the same lengths, but all the angles are the same. And if all the angles are the same, what does that mean about their ratios?
They all have the same ratio.
Right? They all have to be the same. These have names in mathematics because of this relationship. Any triangle that has these ratios is going to have the exact angles of this triangle. Anytime you come across a ratio of opposite to hypotenuse of 0.4, it'll be that angle. Every time. Because that angle, right? If you have, let's say it's I don't know what it is. Actually, I'll find out what it is.
I've seen that president today.
Hold on. Arden, I'm gonna need you to do me a favor in a second. Can you do that? Or no? Can you measure this angle, Arden? That little X right there? We'll see if I'm right. This is what I think.
I'd say 32.
Pretty close.
32.
Okay. So I said around 29, so let's say it's around a 29 or 30 degree angle. We'll meet in the middle. Okay? It's almost a 30-degree angle. Maybe 31, maybe 29, somewhere in there. Anytime you have this ratio, that angle is going to be 29 degrees, 30 degrees, whatever it is. Anytime. Okay? All of these angles, in fact, are all 29 or 30-ish degrees in there. Okay? Because, again, if they're all similar triangles, if they have the same angles, we know we talked about that scale, right? The scale major, the scale between the sides is going to be the same. That's the whole entire definition we've been working on with similar triangles. Okay? Same thing we can think about in construction, right? The truss back there has a 5/12 pitch. Okay? The truss on that wall. On that wall. Look at it. That truss has a 5/12 pitch.
I'm sorry, you're more right. Yeah, it's more like
Cool, thank you. That truss has a 5/12 pitch, and it's a 10-foot wide bottom plate, right? The bottom of that truss, you can pick that up. The bottom of that truss is 10 feet, okay? Now, the angle on the top of that truss, because the pitch is 5/12, that doesn't matter if we're talking about a 10-foot plate or a 20-foot plate, because the pitch is going to be the same, right? The slope is going to be the same. Here's what we're talking about in your notes. These ratios, these three ratios, have names. We're going to talk about their names right now. Stop. The first ratio that we talked about, the opposite to hypotenuse ratio, is called sine. Sine is the ratio of opposite divided by the hypotenuse. It is abbreviated as SIN. You will not call it sin, you will call it sine. Yeah. Sine is the ratio of the opposite to the hypotenuse. SINE. The calculator button says sin, but it's not sin, it's sine. Okay. As we move along, maybe you recognize, right? How many ratios are there? 3. One of them is sine. You already look, if you look at your calculator button, you can see the other 2. The second one is cosine. Cosine is the ratio of the adjacent to the hypotenuse. Oh, no. It's just the ratio of opposite side adjacent. It's not from the 90. I'll talk. Okay, cosine, again, you're not going to call it cos, you're not going to call it cos, you're going to call it cosine. That's its name. Even if when you write it and when we use it in an equation, we'll use it as COS and we'll say cosine. The ratio of adjacent to hypotenuse. Sine, cosine. Has anyone heard the third one before? Tangent. Yeah. Tangent. Tangent is the ratio of the opposite side to the adjacent side. Again, this page of notes is going to be your most referenced page of notes over the next several months. I encourage you to write clearly, legibly, and write down everything that I'm writing.
Are we going to call that?
It's called tan.
Why can't we call it tang?
3 letters. I don't
We can call it tab.
Let's just call it tangent. tangent. How about we just say okay, sine, cosine, tangent, ratio of opposite to hypotenuse, adjacent to hypotenuse, opposite to adjacent. We'll work that later. Okay. So now this doesn't yet answer our question of how to find the angle. That question, that answer's a little ways away. But we can talk about how we find sine, cosine, and tangent for a triangle. Okay? So we're going to do one example. You should. Example. I'm on the next page. That's where I'm at. Because I wrote the G4 stuff first. I would like you to find, and here's how I'll write it, sine of x, cosine of x, and tangent of x on the following triangle. I need everyone right now to try this. I need everyone to try this. Right? The process of learning, actually physically, what happens in your brain is when you're at something you know and you're trying to go someplace you don't know. Okay? So all of you try. I don't care if you're wrong. I don't care if you write something wrong. But please write something. What you would guess if you had to write something. Forced your pen to the page. What would you say, or what can you come up with as the sine of x, the cosine of x, and the tangent of x? Try all three. I'm going to give you about 50 seconds. You might have not known how to write it. That's okay. Right? So long as hopefully you tried to write something. Someone feeling confident?
I'll do it.
I want you to give me this. Sine is blank, like what sides, what definition-wise? What's sine defined as? What are your numbers? What's your end result? Okay? Who's feeling real confident about it? You don't raise your hand. Kimani, go ahead. Just start with sine of x. What's its definition? I'm going to stop you right there. Okay, so let's try again. Sine is, which in this case would be, which would equal, beautiful, just like that, just like that. For cosine, Zadaya. Whoa, you got to start with cosine is. And beautifully said. Last one. Go ahead, Matthew.
Tangent. Wait, me, right?
Yeah.
This is the ratio of opposite over adjacent, and I got 6 over 8 equals 0.75.
That was just on that worksheet. You might have called that 0.8. We'll talk about like when you're rounding. It's okay if you call it 0.8. Okay. Beautiful. Okay. What I need you guys to do right now is you need a scratch piece of paper that you are going to be giving to me. If you need one, I can hand you one. It only needs to be as big as like a quarter sheet. You can share one page in your table. So share. Aha moment you've had this past week. Okay, that might include, and I heard a lot of you guys today, it might be something, I don't know, some moment where you've been struggling with something and you finally went like, oh, that makes sense. And I want you to take a few minutes, 5, to kind of reflect on the learning you've done this past week. Reflect on some maybe conversations you've had, talking to some people in your groups or your old groups, or even today. Like maybe tell me the story. What happened? Who explained it to you? How did that help? Some of you guys maybe went to Saturday school and you're like, oh, that finally made sense. Okay? If you're like, you know what, I'm still feeling really struggling, then tell me about that. Tell me something you're struggling with. Tell me why you think that is. Tell me how we might make that so it's not a struggle for you. But I will ask that for the next 5 minutes, you guys spend some time reflecting a little bit on what we've learned today, what we've been doing on instruction, okay, some of the work we've done the past week, and go ahead and give me a thoughtful reflection, okay, individually. I would love you to include your name, yeah. Yeah.
This has to be on this class.
If you've had something else in a different class you want to share, that'd be cool. But yes, I did want it about this class.